All right. So my number one is saying the height centimeters and edges years of a random sample of 10 farmers are given in the table below. We have heights, we have edges, right? Here we are having 15647. We are having 151. Then we are having 38. We are having 152. We are having 116, 146, 157, 149, 142, 158, 140. We have 44. We have 55. We have 46. We have 49. We have 45. We have 30. We have 45. We have 30. So here is a table showing ages and heights of a group of 10 people. Part A, they are saying calculate the rank correlations coefficient, the rank correlations coefficient. Those were 6 free marks. 6, that was Roman 1. Roman 2, comment on your result. Comment on your result. That was, yeah, the whole thing, 6 marks. Then B, plot a scatter diagram for the data. Plot a scatter diagram for the data. That was Roman 1. Okay, hence, draw the line of the best fit. Let's draw the line of the best fit. C, use your diagram to find, use your diagram, let me say in B, to find 1, y when x is 147, and Roman 2, x when y is 43. These are the numbers that looks to be very, 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 very easy, that can prove to defeat us properly, that can prove to defeat us very, very, very properly. So now, members, if we were to do this question and you really satisfy someone that you have done it very well, okay, you need to really put in. You need to really put in. So Now, basically here, calculating the rank correlation coefficient. Let me hope that most of us, if not all of us, have covered this thing. So what I'm going to do, hope we have copied it already. What I'm going to do first, I'm going to, let me first capture this. Okay, so we are going to rank. So what do we need? We need the heights. We have heights. We can call X, we can let H to be X, and we can let the edges to be represented by Y. So we shall have the rank in X, we shall have the rank in Y, we shall have D, right? We shall have D, which is the same as the rank in X minus the rank in Y. Then we shall have the D squared. So we have 157, we have 151, we have 152, we have 160, we have 146, we have 157, we have 149, we have 142, we have 158, and we have 140. All right. And for Y, we have 47, we have 38, we have 44, 55, 46, 49, 45, 30, 45, and finally 30. Now rank. We need to rank. Now, when we are to look at the ranks of X, the highest is it? Is it 160? We'll give it rank 1.
Excuse me, teacher.
Yes, please.
That value, that first value, eh?
Oh, yeah,
it
yeah.
153?
It's 160.
160 is the first highest value. Then the second one is 158, right? Then the third one is 157. Then there we go to 156. From 156 we go to, is it 152? Yeah. Then 151. Then from 51 we go to 149. Then from there 146. From 146 we go to 142, and finally 140, ranked number 10. Then for ranking Y, or the heights, the highest one is it 49?
Yes.
55. We have 55, then we have 49.
49.
Then
47.
we have 47, then
46.
we have it
46.
as 4 here, then
45, there are 2 times.
40,
45 there are 2 times.
45. So this one would be 5 and this one would be 6. Then you take the average, isn't it?
5.5.
So it will be
Yes.
5 point what?
0.5.
We have 5.5. What is it? 45. We have 5.5. Even here we have 5.5.
Then 44.
44 will take rank 7 now,
So
isn't it?
Yes.
Yeah, 7.
Then 38 will take rank 8.
8.
Then 30, 30, 9 and 10 by average, you'll get 9 point what? We have 9.5 here and 9.5 there, isn't it?
Yes.
So this is these are the ranks.
Yeah.
After ranking, there we shall have, we take the differences in the ranks, and to take the differences in ranks, just subtract, very easy. So here the difference is 4 minus 3, that is 1, 6 minus 2, that is -2, -2, 0, 8 minus 4, 4, 3 minus 2, 1, 7 minus 5.5. You get 1.5, right?
Yes.
9 minus 9.5, you get -0.5. 2 minus 5.5, you get -3.5. Then 10 minus 9.5, you'll get 0.5. Then when you square D, you get 1, you get 4. Someone is saying I'm too fast. Really?
No.
Not really. Then this is 4. This square is taking the difference. It doesn't need me to first put on a calculator. So this is 0. 4 squared is 16. 1 squared is 1. 1.5 squared is 2.25, right? Then -0.5 squared, this one gets to 0.25. 3.5 squared, 9, 10, 11, 12.25, right? Then 0.5, this one gives 0.25 when you square it. So that is my table, but your table should be dressed very well. Don't leave it open. Now we need to take the summation of the d squared, because from the formula we need that summation, right? So the summation of d squared equal to 1 plus 4, 5 plus 4, 9, 10, 36, 38.25, 38.5, 38.75. You help me here. 20, 24, 26, 28. Oh, yeah. 40, 25, 5, rather 255. It gets to 41, 41, 42. I'm getting 41 total.
It is 41.
41, good. So they want us to calculate the rank correlation coefficient. So here, one is free to use either Spearman or Kendall. But according to the way we've done, we have used the Spearman, and that is the easiest. So we shall have that the correlation coefficient would be 1. This formula, you have to get it in the head. If you can't get it during the exam, You ask for the
So what?
for the table. You ask for the book of tables of values. These formulas you can just go and pick it there and you write. Some students don't get these things in the head. Summation of d squared out of n squared minus 1. The moment you write this formula badly by saying 1 minus everything then over, it will give you a wrong answer. And even if you get a correct answer, but when your formula is wrong, you realize that you will be wrong. So it is 1 minus 6 times summation of d squared, which is 41, out of the number of items were 10 into 10 squared minus 1. So this is going to be 1 minus 6 times 41. This is 6 to 41, or rather 246. So up I have 246. Then this is 100 minus 1, that is 99 times 10, 990. Isn't it? So by calculating, this is going to be, oh, someone help me, 0. What?
0.7515.
7515. That is my correlation, my rank correlation coefficient, rho. Interesting. Now, after getting this rho, they want us to comment. They want us to do comment. Now, if I can assure you, and if I can remind you of the comments we do make, you need, here you have gotten this, but what if you get some other value next time? So let me give you a summary of how best we should always be commenting depending on the values that we get, okay? You realize that if you have the coefficient between 0 to 0.200, we say that this is a very low positive correlation. That's what you should be knowing. Very low positive correlation. If you have 0.21 up to 0.40, still, now this is not very low, but low. We just say low, or one can say weak positive correlation. A weak positive correlation. If we have 0.41 up to 0.59, one, we'll call this one moderate or moderate, depending on how your pronunciation was taught. Moderate positive correlation. If you have 0.6 up to 0.79, we say that this is a high positive correlation. High positive correlation. If you have 0.8 to 0.99, 0.99, we say that this is a very high positive correlation. And if we have a correlation of positive 1, we say that this is a perfect positive correlation. Perfect positive correlation. The reverse is true for respective negative values. When we were being taught, English used to be the problem. When they would say the reverse is true, I would ask myself, now what is reversing? Meaning, when they are negatives now, when they are negatives, the reverse is true. When you have 0 to negative 0.2, now that one will be perfect. When you have -1, it will be very low. So the reverse is true for negative, Meaning for negative values, the order changes for statements. You get my point, guys?
Yes.
Now, in our calculation, we happen to get rho as 0.7 what? It was 7515. So I'm asking myself, what should be our comment? You need to first acknowledge that it lies between this. So to save time, one would say there is a high positive correlation between heights and ages of that group that was considered, which were they farmers? Yeah, they were farmers. So comment from the question from the statements and the correlation coefficient we've got, one would say there is a high positive correlation between heights and ages of farmers. As simple as that. So that is part A. I don't need us to argue too much there. Maybe in case there is a question, but I would really love to rush to part B, the scatter diagram.
Excuse me, sir.
Yes, please.
Excuse me, teacher. What is a correlation?
Correlation is comparison. When I say correlate your value with my value, compare. So we are looking at the relationship. Correlation is the study of the relationship between two or more variables. That measures the degree of relationship between given variables is what we call correlation coefficient. The degree, to what extent are these people related? This one is my cousin brother, this one is my cousin sister. To what extent? You find some people perfect that and they end up marrying. So anyway, that is where the rank correlation coefficient of theirs run up to. But in whatever you do, if you assume that person X is your friend, what is the correlation coefficient of your friendship? If it is 0.21 to 0.4, you can just take pi as pi. But if the rank correlation coefficient of your friendship is between at least from 0.6, and most of us grade people by the way, I say this person is having this rank coefficient of this. So it depends on how one, but I think you get the point. Relationship. Relationship. Okay, part B of the question, they want us to plot a scatter diagram. The word is scatter. Scatter. So you have to really plot a scatter diagram. A scatter diagram. I don't know if you guys were taught candles, but we may not. Let's take.
They told us this university.
That it is very hard because it has agreements and disagreements, but it is easy also, but let's leave it. When you use candles, the commenting changes. For this particular case, we're going to have something like substantial positive correlation, but let's take rank, let's take Spearman. Let's take Spearman. Now, part B, part B, they want us to do what? To plot a scatter diagram. You must use a graph paper. 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 You must use a graph paper, and you must respect the scale. We have a height, we called it X, therefore it should come on X. Height in centimeters, X. Then we had edges here, which is our Y. All right, so in your plotting, we have the least value of edges at 30. So one can begin from over 20, wherever. One can begin from 20 to 30 to 40, 50, 60, 70, 80, 90. Did we reach there? But let's take this. All our things are lying within. Even if someone started from 10, so that the graph be up. Then for the height, we have our list, our smallest height as 140. So I can begin like from 130. Each axis needs to have its starting point. Don't assume that it's 20 and then here you start from somewhere. No, if this is starting from 20, what about the x? 130, one can say 135, 140, 145, 150, 155, 160. Did we go beyond that? Even we didn't reach. 165. You plan well for your graph. I guess we can sketch, or rather we can plot 156, 47. I would really need you guys to plot this in your graph papers and maybe you show me what you would have gotten. 156, we are somewhere like here, and 47, somewhere like here. 151, 38, 151, 38, somewhere like here. 152, 44, 152, 44, somewhere like here. 160, 55, 160, 55, somewhere like here. I'm not very accurate. 146, 46, 146, 46, somewhere like here. I've told you I'm not accurate. 157, 49, 157, 49, somewhere like here, close to 50. 149, 45, 149, 45, somewhere like here. 142, 30, 142, 30, somewhere like here. 158, 45, 158, 45, somewhere like here. 140, 30, 140, 30, somewhere like here. Now, ladies and gentlemen listening to me, they say that we plot a scatter diagram for the data and hence we draw the line of the best fit. Wow. Now, to draw the line of the best fit, we've just drawn up, we've just plotted a scatter diagram, but there is an accurate method of drawing a straight, of drawing the line of the best fit. And that one is always you taking the mean average of those points given. That is the very, however, optional. It is very optional. So it is not very necessary getting the mean point. But if you want to be accurate with your value, if you want to be accurate with your value, what you do, you get the mean position or the mean point. So the mean point is denoted by X bar, Y bar, whereby you'll take the mean point, rather the mean position, since it is not necessary, even a student can do it from the table. You can sum up all those ones of heights, the heights, you divide them by 10. You get the value of X. You get the ones of Y, you sum them, you divide by 10. You get the value of Y. Then you plot this value of X bar, Y bar. Where that value is, where you plot it, maybe I'm assuming that it is this one. You draw the line of the best fit passing through that line. Or else you can use your eyes very well to draw the line of the best fit. You can really see that if I split these points, I cannot give you a formula of drawing the line of the best fit apart from this. Okay, I cannot give you a formula of getting the line of the best fit. But if you can use your eyes very well, one can say One can say that my line of the best fit is passing through these points. Okay, so as I've told you, I may not be like the formula is this, you must use this. No, we don't have a substantial formula that you can use to draw the line of the best fit, unless one wants to plot the mean point. But with your eyes, you can draw the line of the best fit. Any question?
Excuse me, sir.
Mm.
I plotted that graph, and you know what I did? I like, for me, I counted like each side. I made it equal. Then I do the line of the best fit. This side
You
I had
plot a
before,
graph,
the other.
you'll send that graph to me, I see. Because I guess it comes out very well. Because some points must lie on a line, some must be out, up, and others on the downer side. So you plot and you show me so that I see the line of the best fit you have drawn for this particular graph. All right. Then from here, they want us to find what? Use your diagram in B to find y when x is 147 and x when y is 43. That is just very easy. You correlate. You correlate. Find y when x is 147. If x is 147, what is the value of y? You correlate and you get it. If they give you the value of y, what is the value of x? You match and get it. Isn't it, guys? Yes. Then there is a question that wanted students to get the equation of the line of the best fit. Yes, Rachel.
Teacher, this question from the 2B, we were not given the x and the y. How do you know that this is the x and this is the y?
We take an assumption that what comes first is x, what comes next is y. What is dependent and what is independent?
Yes, sir.
Have you gotten the terms that I've used, dependent and independent?
Yes, teacher.
But you may not over-reason it out. Hate depends on age sometimes. Maybe unless there is some dwarfism and other genetic disorders. But in most of the cases, but I don't know why some of us are very short, but not too short. But when I was 12 years, it is not the same way I am now. So my height depends on my age, but mathematically you may not over-reason that. That's why we say use height as x and age as y. All right. There is a year that was UNEB of 1998 when they examined the students getting the equation of the line of the best fit. Someone is saying that the graph is small. Have you plotted it, Vincent? Have you plotted it?
Yes.
You have plotted it. You use appropriate scale. The moment you draw something like this, we shall give you marks like this. Use the appropriate scale. You can jump 10 squares. 10 squares. 10 squares. Don't just use 5, 5, 5, 5. Let your graph occupy almost a half a page of your paper. or beyond that. Okay. So now, members, I don't want to take you quite far as this one is concerned, but now assume that they have brought a question whereby after drawing the line of the best fit, they want you to get the equation of that line of the best fit you have drawn. What do? You have to use gradient approach. Okay. You have to use what we call the gradient approach. If you have a straight line, can you pick any 2 points lying on that line? If you're lucky and maybe some of the points you plotted lie on the straight line, that line you have plotted, then it means that those points can give you the very accurate points. You can pick a coordinate here, you can pick a coordinate here. You get the gradient and use that one to find the equation of a line. Is it okay? Is it okay?
Pardon, teacher.
How do you get the equation of a straight line from your O level? You need 2 coordinates, isn't it?
Yes.
Maybe A, B, C, D. So on the line you've drawn, you can pick those pairs of 2 points, isn't it? You can pick a coordinate here of X, Y. You can pick a coordinate here of X, Y. Look for the gradient. The gradient would be D minus B over C minus A. You get the gradient of that line. After getting the gradient, then you can assume another point, maybe XY, to get the equation of a straight line. Is it okay?
No. How do I assume that
Members,
the
you
other
have
point
forgotten O level
like
work. If I have 62 and 54 as my coordinates, can I get the equation of a line?
Okay, yes, you can.
That is what I mean. You will go on your line, pick 2 points that lie on the line, get the gradient, like the way you would have done for this. Because if this point is 62 and maybe this is 54, I mean, get the equation of the line passing through these points. Whereby you'd first get the gradient. The gradient will be change in Y out of change in what? Change in X. It would be 4 minus 2 out of 5 minus 6. That is 2 over -1, which is -2. Then now you assume another point to be passing through this line, and that point is X, Y. You deal with it with one of these points, maybe 6, 2. So you have this. Since it is a straight line, they must be having the same gradients, meaning that if I'm to get the gradient of this point and this point, it will be Y minus 2 over X minus 6, which should be equal to -2. Is it okay? You get the line. So Y minus 2 is equals to -2X plus 12. So you get your Y as -2X plus 10 plus 14. That would be the equation of the line of the best fit. Am I very clear?
Yes, teacher.
Even in 1990, they brought a number that had getting the equation. I'm going to send the question to you. Even 1994, they brought that number that involves you finding the equation. Even in 1995, the same. Even in which other year? I think those. Yeah. Yeah. Yeah, even in 2012, they brought just a scatter diagram and drawing the line of the best fit. Yeah, 2012. So it was number 12. You can have yourself practice all that. Can I go to another question?
Yes,
Yes.
teacher.
Another question that follows there is a mechanics question, which we have covered because we've covered those stuffs. Okay, let's see. A mass of 12 kilograms. That question is very wide, writing it. A mass, I'm going to summarize the question. A mass of 12 kilograms rests on a smooth inclined plane which is 6 meters long and 1 meter high. The mass is connected by a light inextensible string which passes over a smooth pulley fixed at the top of the plane to a mass of 4 kgs, which is hanging freely. With the string taut, the system is released from rest. The system is released from rest. A, find the Roman 1 acceleration of the system. Roman 2 tension in the string. Tension in the string. That was taking 8 marks. B, determine 1, the velocity with which the 4 kilogram mass hits the ground. Roman 2, the time the 4 kilogram mass takes to hit the ground. 12 marks. Very, very, very perfectly easy. There is no question easier than this. There is no question. There's no question easier than this. Now, sketch is the main important thing. I hope we've finished copying this question. So I'm rubbing off this one so that I attempt it. Well, I'm having a mass of 12 kilograms resting on a smooth inclined plane. On a smooth inclined plane. Remember, when the inclined plane is smooth, then there is no friction of force. So I'm having that is my smooth inclined plane, and I'm having a mass of 12 kilograms. So if the mass is 12 kilograms, then of course this one must be inclined on a certain angle, alpha. If the mass is 12 kilograms, then its weight is 12g. This mass has gotten, we have the normal reaction of the body, and then since it is placed on an inclined plane, we need the components with respect to the weight. So the component here is 12g cos alpha, and the component here is 12g sin alpha. All right. Then they are saying that smooth inclined plane, which is 6 meters long and 1 meter high. The mass is connected by a light inextensible string which passes over a smooth plane at the top of the plane. So at the top of the plane, we've gotten a smooth plane where the string is passing, and within this string, in the string there is a force that we call tension. Now, they're saying that this string goes to the mass of 4 kilograms that is hanging freely. So here, that is where I'm having my 4 kilogram mass. And its weight is 4g. Still, this string is the same string, meaning that the body is accelerating like this. The system is accelerating like this. So, I need a question. Any questions so far? But before you ask, remember, the inclined plane is 1 meter high, meaning that the height of this inclined plane is 1 meter. In other words, what I'm trying to mean, if you have it like this, if it is 1 meter high and 6 meters long, meaning this is the length of the plane. So this is 6 meters, and this is my alpha. By having opposite and hypotenuse, I can know what sine alpha is equal to. Sine alpha will be equal to opposite of hypotenuse, which is a 60 or 160. If you know sine alpha, you cannot fail to know cos alpha. But anyway, according to what we shall resolve, let's first resolve and we see. For 4 kilogram mass, I told that when we are working on these forces, we consider one weight up after the other. So for 4 kilogram mass, who can tell me the resultant force? the resultant force with respect to 4 kilogram mass. Remember, the body is accelerating downwards, meaning that this weight is counteracting any other force within the string connected to that very same mass. So what is the resultant force?
Tension minus 4G equals 4A.
No. I just need the resultant force. The resultant force is equal to, I've not yet applied F is equals to MA. So what is the resultant force alone?
T minus 4G.
Where is the body accelerating to?
4G minus
4G minus T.
It is 4G minus what? Minus T. Since the body is accelerating downwards, T cannot outweigh 4G when the body is accelerating downwards. It means that this 4G is moving all the forces. So for 4 kilogram mass, we have 4G minus T, implying that if we apply Newton's second law of motion of force is equals to mass times acceleration, it will be force, resultant force, which is 4G minus T is equals to 4A. Force, that is the resultant force, is equals to mass, which is 4, times acceleration due to gravity, rather times acceleration, A. I call this one my equation 1. What about for 12 kilogram mass? For 12 kilogram mass, what is the resultant force?
All right. It is 12 equals alpha.
Members, you have forgotten these things. You have forgotten these things properly. We looked at all these things. So in this case, since the body is accelerating upwards, I don't expect you to bring in the course. We are looking at
Teacher,
where
it
is the body going to.
Teacher, it is T.
Mm.
T minus 12G sine alpha.
Very good. It is T minus 12G sine alpha. That is the resultant force. You get it? T is moving, or T is moving the whole body up, but there is this opposing force, or there is this force in the opposite direction. So it is T minus 12G sine alpha. So that the overall equation becomes T minus 12G sine alpha is equals to 12A. Equation 2. Now, are we together with my equations? But remember, this sine alpha is equals to 1/60. It is equals to 1/60. Did you get where, have you understood where I got the 1/60? They told me that the length of the plane is 6 meters and that the height of the plane is 1 meter. So by SOHCAHTOA, I can come up with the sine alpha. Am I clear?
No.
So if we had summarized this from equation 2,
Yes, sir.
from equation 2, I think we can reform that equation. T minus 12G sine alpha is 1/60. This is going to be 12A. So this is T minus 2G, because this one is going to be 2, is equals to 12A. Now, considering if you deal with this equation, if you add the 2, if you add equation 1 and 2, you can eliminate that T, because here you have minus T and here you have T. So if you add equation 1 and star, you have 4G plus negative 2G, that will be 2G, is equals to 4A plus 12A, that is 16A. And this one will give me my acceleration as 2 times G, which is 9.8, everything over 16. This is 9.6 over 16. 19.6 out of 16. And this one will give me my acceleration as My acceleration as
It is 1.225.
1.225 meters per second square. As simple as that. As simple as that. Now, it's from this background that we can get the tension. Since we have equations 1 and 2, you can substitute in the easier one and you get the, I can get the tension. So from here, you can see the tension will be equaling to 12A from this equation, from star T is equal to 12A plus 2G. So our tension is equaling to 12 times 1.225, which was acceleration, then plus 2 times 9.8. And this one will give you a tension in newtons as
It is 34.3.
34.3 newtons. Now, part B of the question. Determine the velocity with which the 4 kilogram mass hits the ground. Remember, they said that with the string taut, the system was released from rest, meaning that our initial velocity is 0. They need a final velocity with which the particle hits the ground. We have our acceleration already as what? As 1.225. We have the height, because since it is going to hit the ground, and we have the height or the distance it will cover as 1 meter. The value of S would be 1 meter. So there is nothing that can stop a student from using the third equation of motion of V squared is equals to U squared plus 2AS. So V squared is equals to U squared, which is 0, plus 2 times 1.225 times S, which is 1. So V squared is going to be equal to 2 times 1.225. This is 2.45. So by checking the square root, we shall get our velocity as
1.565.
5.5652 meters per second. So this is the velocity with which the body hits the ground. Then B Roman 2. B Roman 2 is saying the time the 4 kilogram mass takes to hit the ground. Since we have the final velocity V as 1.5652, and we know that our U is 0, and we know that our A is 1.225, and now they need T. I can use the first equation of motion. V is equals to U plus AT. So 1.5652 is equals to U, which is 0, plus acceleration, which is 1.225, then T. Okay, so my time will be equaling to 1.5652 over 1.225. And this one will give me my time as how many seconds?
1.28 seconds.
1.28.
28 seconds.
1.2
8.
seconds. 12 marks. I think passing members is very easy. Now that is the number of mechanics you have picked. So I told you that there are those mechanics numbers which you must pass. Okay. Okay. I'm enjoying the applied here. Now, we've done a number. We've done a number from statistics. We've done a number from mechanics. Can we do a number from numerical within the same thing? Because I wanted at least us to do from each. That number 11, I would do number 11, but I wanted us to pick from, the time may not allow us to do all, of course. So I wanted us to get one from numerical out of what we are having, out of the work we are having. Wanted us to get one from numerical. Then maybe we see. If time allows, we can do that number 11 of the probability density function. Can I pick one from numerical also?
Yes.
Yes, sir.
Can I do the one which involves a flow chart or the one which involves errors?
Errors.
Mhm.
Errors.
The flowchart.
Errors, the majority.
Okay, let's do both. I know time will allow, because errors I will just simplify them
Flowchart.
since we are the. Okay, let's begin with like a flow chart very fast, because
Yes.
okay, it exists as number 15 there. It exists as number 15. Show that the iterative formula, I'm not writing all that, based on NRM, if you hate it, you die. Show that the iterative formula based on Newton-Raphson's method for solving the equation ln x plus x minus 2 is equals to 0, this is the formula, is given by, they want us to prove this, xn plus 1 is equals to xn into 3 minus ln xn, everything is over 1 plus xn. For n is equals to 0, 1, 2, and other values. I guess most of us can do that. Then let's first prove that. Then after we follow the question the way it is, because after you want us to construct a flow chart. But let's first simplify this very fast. If we are given a function, we shall have that our function of xn is equals to ln xn. The moment you say xn, everything has to have a subscript xn plus xn minus 2. This is my function. Then I find its derivative. The derivative of xn is, when you differentiate ln xn members, what did we say? What do we get? We get 1 over xn, isn't
1 over
it?
x.
Plus 1. Now, after having gotten this, you know, you can make this one by taking the LCM, and it becomes 1 plus xn out of xn. Are we right?
Yes,
Yes, sir.
teacher.
I guess yes. Okay. Now, since we are right here, then I can bring in the aspect that xn plus 1 is equals to xn minus f of xn over the derivative of xn. Interesting. This is quite interesting. Substitute, it will be xn minus the function, which is ln. The moment you say minus and you don't put a brackets, we also don't put a bonus 1. So xn plus xn minus 2 out of f of xn, the derivative, which is 1 plus xn out of xn. All right. So this is going to be equal to, of course, this one, when you're dividing it means that the reciprocal. So xn is multiplying into this, isn't it? So I'm having xn minus minus xn into ln xn plus xn minus 2 out of 1 plus xn. I guess I'm right. This is equal to xn into 1 plus xn minus, you can expand, xn ln xn, xn ln xn plus, minus xn squared plus 2xn out of 1 plus xn. This is xn plus xn, x squared n minus xn ln xn minus x squared n plus twice xn out of 1 plus xn. Xn squared will go with xn squared. Don't cancel in an exam. I'm just showing you. Then xn plus 2xn, it merges to be 3xn minus xn ln xn out of 1 plus xn. Factorizing out xn is the biggest deal. After all, yeah, even it is factorized in the proof. So this is the same as xn into, when you factorize out xn, you're remaining with 3 minus ln xn out of 1 plus xn. I want to assure you that within no minutes we have scored 4 marks. Within no minute, you've scored 4 marks. Then after that, they want you to draw the flow chart. You know the rules. They want you to draw the flow chart that reads the initial approximation error. A flow chart that reads the initial approximation error. When they want us to plot to draw the flowchart that reads the initial approximation error, you need to first find out the details that you want you to put on the flowchart. It reads the initial approximation error, that is 1. It computes using the iterative formula in A and prints the root of the equation. So it prints the root of the equation, that is xn plus 1. So it prints out xn plus 1. When an error is less than, we say that error gives us what to put in the other tolerance box. So the error is 1 times 10 to the power negative 4. Oh, Jesus Christ. Now here, you can draw your flow chart with a lot of love. With a lot of love. How do you start? What should I put here?
Start.
Because you are telling a machine what to do. This machine is idle. A computer is idle. It is you to tell it what to do. Okay, Mr. Computer, start. You want me to start, but what should I start with? I'm assuming that I've not yet given it any iteration to make. So I'm beginning with the number of iterations as 0. Then this machine, before, as it is starting, it must read what you have put, and the read box, we say that we draw it in a parallelogram format. So in this parallelogram format shape, the machine is reading, but what is the machine reading? You have been told that let it read initial approximation error. Or one can say read xn is equals to error, the initial approximation xn is equals to error. Then now, after it has read, then it has to substitute, or it has to, you have to feed the formula. If it has read the initial approximation, you have to feed in the formula. Formula box, you draw it in triangular shape. Rather, is it rectangular? Sorry, rectangular. In this rectangular shaped figure, you put in this rectangular figure, you put the formula that you derived, which was xn. One may be like, hey, what if I failed to derive it? And now I put it here. Still you marked because the other part is independent. So it is xn into 3 minus ln xn out of 1 plus xn. Then it is from this, after having fed in, remember you read this, now you are going to feed it in, and then you ask yourself, is xn plus 1? In case you missed these members, I uploaded everything. So you'll be asking yourself, is xn plus 1 minus xn less or equal to the error, which error is 1 times 10 to the power negative 4? Question mark. Without a question mark, you are getting it wrong because you're asking yourself, is it less or equal to that? In case they have not given you the error in exponential form, sometimes they say 3 decimal places, 4 decimal places. If they say 3 decimal places in your tolerance box, you'll be saying, is it less or equal to 0.0005? Because you have to get us the maximum, you have to get the error. Here you will put the error. Then the answer is either no, or the answer is yes. If it is yes, you print out. You tell the computer, okay, now since I have gotten a positive response, you print out. But what am I printing? I'm printing the root. So you're printing xn plus 1. And after printing, does the machine keep running? No, you have to stop it. But in case the machine tells you, no, it is not yet over, you have to come and increase the number of iterations. Equal signs, you are okay. One can say n, you increase to n plus 1. Then you can also, here you have to increase the xn and it will go to xn plus 1. After which you have to bring and you substitute in the formula afresh. That is what we call a flow chart. That's what we call a flow chart. Is it clear, members? Is it clear?
Yes, sir.
Excuse me, teacher.
Yes, please.
Now, for cases where the answer is yes, yeah? Do I have to continue
you
do I have
print.
to continue?
When the answer is
with
yes,
the no?
When the answer is yes, you print and stop. And you print, the output should be what you are told to print. If you are told to print the root, you say print the root, you put it, and then you stop.
So I don't show the other side of no, eh?
No, this is the general format. The other branch of no must be there because you don't know what the machine will tell you. It can tell you a yes or a no. In other words, this is the general format of presentation. Okay. You have to include both parts. All right. Okay, for further reads, members, you consult the numerical upload I made. All of it. Then from there, the last part is perform a dry run of the flow chart when error is 1.6. They want us to perform a dry run. When they want us to perform a dry run, they've given us that when error is what? When error is 1.6. Error is our initial approximation. So what do? Our dry run must be having 4 parts. It must be having the number of iterations. it must be having the xn, it must be having the root xn plus 1, and it must have where we are checking from xn plus 1 minus xn magnitude. We want to see if it is less or equal to this error, and then we shall get our final answer. So when the number of iterations were 0, when we had not done anything, the value of xn, or the initial approximation, was 1.6. After getting the initial approximation, you'll substitute it in the formula of xn plus 1, which is this, and you get the value. So we are getting the value of xn plus 1 after substituting xn into this formula. I told you that the easiest means is to put it in the calculator so that you keep solving. Okay, one can put x on the calculator into 3 minus ln x, because the calculator may not have xn. Then out of 1 plus x. Then you shift solve and you put the value 1.6. So if you put 1.6, you're likely to get 1.5569. 1.5569. And when you take the error, or when you take the difference between these two, xn plus 1 minus xn, you're going to get 0.0431. We had done this very example, I think. That's why I still have the values recorded. And in this particular case, even if you get a negative answer, you take the magnitude, so you have to record the positive. So when the iterations are 2, rather when we go to the second iteration, it means that this one will act as our xn. So it will be 1.5569. When you substitute this value into xn plus 1 formula, you're going to get 1.5571. And when you take the difference between xn plus 1 and xn, you're going to come up with the 0.0002. We go to the second iteration because we want the error to be less than this, meaning the error should be 0 for this case. So when we go to the second iteration, this one will act as our xn. When this one acts as our xn, we shall have 1.5571. And when you substitute in xn plus 1 formula, you're going to come up with the very value 1.5571. And when you take the difference, 0.000, and in this case, what you've gotten as the value of xn plus 1 is our root. What you've gotten is our root. So hence, the root is 1.5571. If they wanted the 3 decimal places, so you can stop 557, 3 decimal places, and you get your 12 marks. That is it. That is it that every other person would have done.
Excuse me, teacher. Excuse me, sir.
Yes, I'm getting you.
Yeah, here on the when drawing this category, on the magnitude, we ask, like we asked here, that we say magnitude of this one, and we show it is less or equal to the error.
Yeah, you can put it, you can leave it, because I'm trying to show you the magnitude is only. But if one wants, you can put less or equal to 1 exponent -4. But still, this is enough.
Yes, sir.
So can we do the number of errors in 15 minutes remaining? The aim of this lesson was to show you that you cannot fail if you are sober enough. You cannot fail. Now these are 3 questions so far from the work we've already covered. So can the time allow us to do the number of errors chap?
Yes, it will allow us.
Okay. Karen, let's rush to the number of errors. The number of errors, they are saying that the numbers x and y are measured. The numbers x and y are measured with possible errors of delta X and delta Y. The numbers X and Y are measured with the possible errors of delta X and delta Y. Show that the maximum absolute error, show that the maximum absolute error, show that the maximum absolute error in the quotient X over Y, in the quotient X over Y is given by this. They have given us the quotient, so they want us to prove that the maximum error is given by magnitude of Y, magnitude of delta X, magnitude of X, magnitude of delta Y, out of Y squared. Numbers, to be on the safer side, even though you've not covered some things like this, I've told you that I uploaded everything. You can cover all that topic on your own. You can cover all that topic on your own, so that you start your revision very, very, very earlier. Very, very early. Otherwise, you may not know how rushing we shall be when we get back to schools. Some things which would be easy, you'd be finding them hard because they are being rushed. So now, like this error propagation in a quotient, we handled it together. We handled it together, the error propagation. So let's see how we come up with a quotient and prove if it will be what? If it will be equal to that. One can use different methods. One can use the binomial theorem method, and one can use the rationalizing. I don't want us to waste too much time. So if I let my z to be equal to X over Y, and if I also let the kz to be the possible error in Z, then it would mean that from Z is equals to X over Y, if I add the errors now, it would mean that Z plus delta Z is equal to X plus delta X out of Y plus delta Y. That is what we are having. X plus delta X over Y plus delta Y. Now this one would be Z plus delta Z is equals to, we rationalize. In rationalizing, we shall rationalize the denominator, and this is going to be X plus delta X times Y minus delta Y. When we are rationalizing, we shall subtract over Y plus delta Y times Y minus delta Y. All right. Normal expansion will bring us Z plus delta Z is equal to, we expand XY. I guess we can expand the screen, yeah, XY, then X times negative delta Y, it will be minus X delta Y plus Y delta X minus delta X delta Y, out of, when you expand the denominator, we shall have Y squared minus delta Y squared. Is it okay?
Yes, teacher.
We know that delta X delta Y and delta Y squared, these ones are too small. and therefore neglected. So we shall neglect them. If we neglect them, it means that we shall have our z plus delta z is equals to xy negative x delta x plus no, negative x delta y plus y delta x. Everything is out of y what? Y squared. We've neglected this and this because they are very small. So it means that our delta z alone would be equaling to xy plus the negative of x delta y plus y delta x over y squared minus z, but z is x over y, so minus x over y. We can take the LCM, so it means that our delta z is going to be equaling to xy plus negative x delta y plus y delta x minus the LCM is y squared, remember, so it will be minus xy out of y squared. Xy will cancel with the negative xy, so we shall have our delta z equaling to negative x delta y plus y delta x out of y squared. Now, when we take the magnitude of both sides, we shall have that delta z is equal to the magnitude of negative x delta y plus y delta x out of y squared. Here, it is a point that we introduce in the triangular inequality. The triangular inequality will bring out, if we bring the triangular inequality, we shall have magnitude negative x delta y, all right, plus y delta x out of y squared. Okay, so this one is going to be the same as, when you take the magnitude, of course, negative will become positive. So it will be x delta y plus y delta x out of y what? Out of y squared. All right, which is the same as, since they have begun with the, even if now from here you write the final expression, there is no harm. So we shall have y delta x plus x delta y out of y squared. You will realize that the expression we derived when we are studying did not have all these magnitudes, but because of the nature of the answer they want, you have to conclude like they have. For more information, you can recap using the lessons that were uploaded about errors. Interesting. So all these ones, members, are supposed to be your marks. Remember, we are in the fourth question. Someone asking?
Teacher, yes, I'm asking. Teacher, here, the y was under the magnitude. Do you just remove it anyhow? Because it was under the magnitude and here it's not.
You're on this step. The value, what we are deriving, for us what we derived was x magnitude of delta y plus y magnitude of delta x over y squared. That is what we derived when we are studying these things. But the final answer of ours is under magnitude. So put everything under magnitude and get the final answer the way they want it. Otherwise, the final thing would be like this. There is a year where I think 2014, where the expression is different from that. It was 2014. 14, yeah. Now in 2014, they wanted the students to conclude like x of y, they wanted students to conclude with the y delta x plus x delta y out of y squared. You see, in 2012, in 2014, that is how they wanted the students to conclude. But a student who brought it and wrote this one still is marked right. Is marked right because the question is show that the minimum absolute error, you must have the magnitudes with you. So a student who stopped, they wanted this, but a student who wrote this was very excellent. And here still, a student who writes up to here, because they wanted the magnitude. So put all of them the way they want, provided you know that from here you can write what they want, it is okay. I won't say that here they can undermark you, they can squeeze you for. Provided you know what is right, you end up, for you must be ending here. But whatever they add on, you also add it. But the final thing would be this. So in other words, they just put the magnitudes on y, just that.
Okay, teacher.
Finally, let's do that final part. In the final part, they want us to find the interval within which the exact value, oh, wow, interval within which the exact value of 2.58 out of 3.4 is expected to lie. They want the interval within which the exact value of this is expected to lie. If we are to get the exact, if we are to get the interval, we need to get the minimum value and the maximum value. Do you still remember? Now.
Yes.
Now. This question, one can do it in two ways. And I think I need to give you both. If you have this value, if I let my z to be that value 2.58 out of 3.4, of course, if I let this one to be my x and this one to be my y, the error in x is what? Since I have two decimal places, the error will be 0.005. The error in y will be what? Who can tell me the error in y?
0.05.
0.0 because of one decimal place, then 5. Now, I can get z minimum and I can get z maximum. Z minimum will be, if I need a minimum number, what do I do? If you need z to be minimum, should this one be big or small? If I need z as a minimum number, what is a small number? What should my x be?
Minimum. Small.
X should be small. So in other words, my z minimum would be x minimum. You will minimize x, but maximize what? Y. That is when you get a small number. So it will be x minimum, you get x, that is 2.58. When you need the minimum, you subtract the error, 0.005 over y we need maximum. So it will be 3.4. When we need maximum, we add the error, 0.05. Am I clear?
Yes, teacher.
So this is 2.585 after adding the error over 3.35. Did they tell us the decimal places in which they want the answer? Of course, yes. No, they did not tell us. So since they didn't tell us, let's appropriately put 4 decimal places.
Excuse me, teacher.
Please.
For x minimum, you subtracted the error, so it reduces.
Yes, when you subtract the error, you're finding the minimum of the value. When you add the error, you're finding the maximum of the value.
And your it is supposed to be 2.575, not 2.585.
It is supposed to be 2.575.
575.
5. Oh, yeah. 575. Hey, me, I added it instead. Then this is supposed to be 3.45. I just subtracted on either. What do you get?
You get 0.746.
0.74.
46. What?
46 what?
It's 467. 37.
Oh,
Then, if we need Z maximum, if we need a maximum value, it means that X should be maximum and Y should be what? Minimum. So even one can add the formula that this is going to be X minus delta X over Y plus delta Y. So it is going to be equal to X plus delta X over Y minus delta Y, isn't it? So it is X, which is 2.58 plus delta X. That is 0.005 out of Y minus delta Y. Y is 3.4 minus delta Y is 0.05. So this is 2.585 out of 3.35. So what do you get?
Which is 0.7716.
Now, after getting the maximum and the minimum value, this is Z minimum. Here you just conclude. The interval is, we first begin, hence the interval is, you write the minimum value, then comma maximum value. So the minimum value is 0.7464, comma 0.7716, and that is the interval. Full stop, 6 marks. Just that. So that is how easy one would get it. Or else one would do it like this. The time has gone, but still I have to. Because when we proved the quotient, we got our delta Z. Let me use equal signs as magnitude of Y dx plus magnitude of X dy over Y what? Y squared. So if I take my X as the way they were given, 2.58, and I take my Y as 3.4, okay? One can use this alternative. Then here, of course, dx is 0.005, and here dx is 0.05. So if you substitute here, you get your dz as magnitude of Y, which is magnitude of 3.4, times magnitude of delta X, which is 0.005, plus magnitude of X, which is 2.58, times magnitude of the other one, which is 0.05. out of y squared. That is 3.4 squared. So you can just compute 3.4 times this plus this times this. Let me put on my calculators. What do you get here when you multiply this? And what do you get? Someone can compute this, someone can compute this, so that we save time. Over
for this one, for the 2.5, it is 0.129. Then for this one, it is 0.017.
When you square. When you square this down.
You get 11.56.
11.56. What do you get overall? This is the same as
you get 0.01226.
0.01226, right? So this is it, that is it.
Yes.
But remember, they want the range within which the exact value. So let's get that working value or the exact value. Working value, which is Z, is going to be equal to 2.58, direct the way they have given it to you, out of 3.4. What do you get?
You get 0.7588.
0.7588. 88. That is the value, the exact value of Z, right?
Yes.
Now, if we are to get the range, we shall need the minimum value of Z and the maximum value of Z. Minimum value of Z would be equaling to Z, which is the 0.7588. We subtract the Z because we need its minimum. So we subtract the Z. So we shall subtract 0.0126. Someone will get me that. Then it's maximum. What do you get?
0.7462.
Which is the same as what we got in the start. Then maximum of Z will be equaling to Z 7588 plus the error 0.0126. What do you get?
You get 0.7714.
Implying that the range or the interval is minimum 0.7462, maximum 0.7714. The same. So still you get the same max. Now, I think every meeting we shall be doing four numbers from section B, and we see how life will take us. I wish you all the best.
This is great.
Sorry?
Thank you. It is a great thing. Thank you, sir.
You're welcome.